Hello everyone, I am Dr. Ganesh M, Associate Professor, Department of Aeronautical Engineering, Hindustan College of Engineering and Technology. In this video, I am going to discuss about principles of measurements. Definition of measurement. Measurement is the assignment of a number to a characteristic of an object or event, which can be compared with other objects or events. The scope and application of measurement are dependent on the context and discipline. Simply, the process of assigning a number to a parameter or feature is called measurement. Characteristics of measurements. Static characteristics, the performance criteria for the measurement of quantities that remain constant, or vary only quite slowly. Dynamic characteristics, the relationship between the system input and output when the measured quantity, measurand, is varying rapidly. Static characteristics. Accuracy, it is the ability of a device or a system respond to the closeness of the true value of the measured variable under the reference condition. Point accuracy. Accuracy as a percentage of scale range. Accuracy as a percentage of true value. The accuracy of an instrument is quantified by the difference of its readings and the one given by the ultimate or primary standard. Next, static characteristics. Precision, it is defined as degree of exactness for which an instrument is designed for. Conformity, significant figure. Precision describes an instrument's degree of random variations in its output when measuring a constant quantity. Next, static characteristics. Repeatability, it is defined as the measure of closeness with which a given input may be measured over again in the same operating conditions. Next, static characteristics. Range or span. Range or span of an instrument defines the minimum and maximum values of a quantity that the instrument is designed to measure. Next, static characteristics. Drift, this is an undesired change or gradual variation in TH output over a period of time that is not related with change in input or output or operating conditions. Point drift, for maintaining the exact operating conditions and maintaining the output variation for the fixed input function at time. Calibrated drift, for maintaining the input signal, the operating condition is constant by comparing the calibrated curve. The environmental factors may cause drift. Next, static characteristics. Reproducibility, the closeness agreement, repeated measurement output for the same input is applied with same operating conditions for a specified period of time. There is no drift. Next, static characteristics. Reliability. Reliability is the probability that a device will adequately perform, as specified, for a period of time under specified operating conditions. Some sensors are required for safety or product quality, and therefore, they should be very reliable. Next, static characteristics. Static sensitivity. Static sensitivity is defined as the ratio of the change in output to the corresponding change in input under static or steady state conditions. Next, static characteristics. Linearity. Linearity is actually a measure of nonlinearity of the instrument. Next, static characteristics. Resolution or discrimination. It is the minimum change or smallest increment in the measured value that can be detected with certainty by the instrument. It can be least count of instrument. Next, static characteristics. Dead space or threshold. It is defined as the range of different input values over which there is no change in output value. Next, static characteristics. Tolerance. Tolerance is a term that is closely related to accuracy and defines the maximum error that is to be expected in some value. Tolerance describes the maximum deviation of a manufactured component from some specified value. Next, static characteristics. Backlash, it is defined as the maximum distance or angle through which any part of mechanical system may be moved in one direction without causing motion of next part. Can be minimized if components are made to very close tolerances. Dynamic characteristics. The dynamic characteristics of any measurement system are speed of response, measuring lag, fidelity, dynamic error. Dynamic characteristics. Speed of response and response time. It is defined as the rapidity with which a measurement system responds to changes in the measured quantity. Next, dynamic characteristics. Measuring lag. It is the retardation or delay in the response of a measurement system to changes in the measured quantity. The measuring lags are of two types. Retardation type. In this case, the response of the measurement system begins immediately after the change in measured quantity has occurred. Time delay lag. In this case, the response of the measurement system begins after a dead time after the application of the input. Next, dynamic characteristics. Fidelity. It is defined as the degree to which a measurement system indicates changes in the measurand quantity without dynamic error. Next, dynamic characteristics. Dynamic error. It is the difference between the true value of the quantity changing with time மற்றும் the value indicated by the measurement system if no static error is assumed. It is also called measurement error. Thanks to all for watching this video.